Everyone in Star Wars hopped around the galaxy willy-nilly, no problem, just smash the button and say some sci-fi gibberish, and zoom! You're going the speed of light or even faster than the speed of light. But is it possible for us meatbags in the real world to travel at the speed of light? That's a good question, a complicated question. First, what is the speed of light? The speed of light is 186,000 miles per second. Let's try to wrap our brains around that figure with some distances. The moon is 250,000 miles away. So the light that is reflecting off the moon from the sun takes about 1.3 seconds to reach us here on Earth. The sun is about 93 million miles away. So light from the sun takes about 8 minutes and 20 seconds to reach your eyeballs. The closest star to us, other than our own star, the sun, is Proxima Centauri. And when we talk about Proxima Centauri and pretty much anything outside of our own solar system, measuring distances in miles and kilometers is just silly. Instead, distances from Earth are measured in light years, meaning how far light travels in 1 year. So, the light from the closest star to our star, Proxima Centauri, takes 4.22 years to reach your face, going the speed of light. We live in the Milky Way galaxy, and in the Milky Way galaxy there are between 200 billion and 400 billion stars. And our little old star, the sun, lives out in the galactic suburbs. If you were to travel at the speed of light from one side of the Milky Way galaxy to the other, it would take you 100,000 years. When you look up in the night sky, you are kind of gazing into a cosmic time machine. And if you've never been in a place with virtually zero light pollution, do yourself a favor and find a place. Based on data from the Hubble Space Telescope, the observable universe is estimated to have between 100 billion and 200 billion galaxies, each with hundreds of billions or even trillions of stars. And when the James Webb Space Telescope launches in 2020, replacing Hubble, those figures are expected to drastically and dramatically increase. This image is the Hubble Ultra Deep Field. In it, there are 10,000 visible galaxies. The closest galaxy to our galaxy is the Andromeda Galaxy, which is 2.5 million light years away from us. Once again, that means the light from the Andromeda Galaxy took 2.5 million years to reach the optical instruments that compiled this image. And the furthest thing we can detect in the observable universe is the cosmic microwave background radiation, which is the very edge of the now observable universe. Oh, it's a big-ass universe with big-ass distances and big-ass time frames. We have learned so much about our place in the cosmos in just the past few decades. The fastest a human has ever gone was during the Apollo 10 mission. The 3 astronauts inside, Thomas Stafford, John Young, and Eugene Cernan, used the moon's gravity to slingshot around the moon, reaching a speed of 24,790 miles per hour. Can a human travel faster than the speed of light? No, we can't. And I hate saying that. The more appropriate response might be not yet. Not according to our modern understanding of physics. The problem with flat out saying no is that perhaps thousands of years from now, some method of space travel will render the question of can we travel at the speed of light kind of pointless. The speed of light might be a constant in a vacuum, but maybe the question is the wrong question to ask when we're talking about setting sail across the vast cosmic ocean. The combination of human ingenuity and time should make anyone hesitate from saying never about anything in the realm of technological possibilities. But objects with mass cannot exceed the speed of light, because they would require an infinite amount of energy. And it gets even more fun. Time, space, speed. Einstein proved that time is not a constant. Rather, time is affected by how fast something moves relative to its surroundings. This is called time dilation. Time dilation is a difference in the elapsed time measured by two observers, either due to a velocity difference relative to each other, or by being differently situated relative to a gravitational field. For example, if Han Solo traveled 99.1% the speed of light from Earth to Proxima Centauri, our closest neighboring star, he would have been gone for a little under 9 years to us here observing from Earth. But to Han, he would have only been gone for a little over a year. And if we take into account the principles of time dilation, the characters in Star Wars would experience some really interesting age variation. But that's a topic for another video. If you've ever laid on your back and gazed up at the night sky in an area with little to no light pollution, you've no doubt seen satellites moving against the sky. In fact, when my wife and I were in the Adirondacks last year, we counted almost 100 satellites zooming overhead in an hour. And what's really interesting is that GPS satellites take into account the predictions of general relativity and time dilation. The clocks on board GPS satellites tick faster than clocks on the ground by 38 microseconds every day. If the principles of general relativity were not accounted for and corrected for when designing these satellites, the entire system would become quickly unusable. Solar sails. Solar sails are one of the more interesting ideas as a form of spacecraft propulsion. This idea is called photon propulsion, and one of the main projects messing around with this idea is called Starshot. The idea is to make a small spacecraft like the size of a saltine cracker, attach some big photon absorbing sails, and fire some big ass lasers at the light sail. The goal of Starshot is to get dozens or even hundreds of nano spacecraft to reach 20% the speed of light, which is 37,200 miles a second or 100 million miles per hour. And at this speed, the spacecraft could reach Proxima Centauri in 2 to 3 decades. It could then take photos of that star system and send the photos back to Earth at the speed of light through radio communication, arriving in roughly 4.2 years. This is plausible, it is probable, it is mathematically possible, and it would work. It's fascinating stuff. So, the speed of light, it's mind-boggling. But for interstellar travel, it just doesn't seem fast enough. Who knows what forms of space travel humanity will discover in the distant future? The possibilities are endless. And as fun as it is to see the Millennium Falcon jetting around, popping in and out of places in no time, the reality of it is that it would take a hell of a lot longer.